Hello, I'm Cheryl McKinney and welcome to the Apples Video Magazine. Many people wonder, what does math look like in a pre-K classroom? Our program today, Meaningful Math Activities in Pre-K, Part 1, will provide a clearer picture of what math activities and skills are developed in pre-K. In this two-part series, Sally Moomaw, an assistant professor in early childhood education at the University of Cincinnati, will address math standards and concepts that young children will need to develop a strong foundation in math. She mentions Common Core standards that are currently developed nationally for grades K through 12. Some states are developing their own Common Core standards for pre-K. Using the latest research, the National Association for the Education of Young Children and the National Council of Teachers of Mathematics have developed a joint position statement called Early Childhood Mathematics, Promoting Good Beginnings. In this position statement, they have pointed out that all young children should experience high quality, challenging, and accessible mathematic experiences. The position statement also points out that young children need a variety of hands-on materials and the time to manipulate and explore with the materials in their play. This play can promote numerous math concepts. We know that children come to our schools or programs already knowing many math concepts. Researchers have also found that math skills are a better predictor of future school success than language and literacy skills. Now let's listen as Sally Moomaw shares ideas that will impact the development of early mathematical skills that will create a framework for school achievement.
Well, for many years in preschool classrooms, we've had a very heavy focus on literacy. But with the coming of the standards movement, which includes standards in mathematics, many states adopted math standards for preschool, and I'm sure many teachers are aware of this. That's been going on for about a decade, but now we have something new coming on the horizon, or it may be there for some of you, and that is Common Core standards. And those have been nationally developed, and many states are adopting them. Standard movements are looked at in a variety of ways by teachers, but one of the positive things that I think it has really shown us is that there is a vast amount of mathematic learning that goes on in ages 3 to 5, and that there's a real breadth of math learning that we need to provide as teachers. So it has really, I think, helped us realize that even very young children are not only counting and finding out how many of things they have, but they're also beginning to add and subtract and divide things up so they can share them, and they're measuring things in the block area. And they're looking at, not just looking at shapes, but actually putting shapes together to get bigger or different shapes. And they're sorting things and beginning to create patterns. So there's a tremendous amount of math that we need to be facilitating in the earliest years. There are actually 5 content areas in mathematics, and all 5 of those content areas should be heavily reflected in the preschool classroom. So let's talk about those for a little bit. The biggest area is the area of number and operations. And in the preschool classroom, that means that young children are trying to figure out how many of something they have, can they get as many as their friend, how many more does somebody have? And this actually is happening throughout the day if teachers can capitalize on it. So for example, in terms of number, if I'm at the snack or the lunch table, I might say, Beth, how many grapes do you want me to put on your plate? And if she gives me a number, say she says 4, I can put some on and say, did I give you the right amount? Check and see, because sometimes I make a mistake, or maybe one fell off my spoon. And then she can use whatever strategies she has to figure out if that was enough. Or if children are playing in the sensory table, I might say, how many ducks swam over to your side of the table? Do you have as many ducks as Ben has? If you and Ben put your ducks together, I wonder how many ducks that would be. Or can you find a baby duck for each mommy duck? And that would be also encouraging number and operations. So this can really go on throughout the classroom. The second area of math content in preschool is algebra, and that sounds ridiculous. No 3-year-old can possibly be doing algebra, but actually they are, because when they sort materials into different groups, that's actually algebra. So let's say they put all the blue teddy bears together, little teddy bear counters together. That's sorting by a particular rule. And when you make a particular rule in math and then generalize it, that's algebra. So if they say, well, I'm putting all the reds together, they've actually formed a rule, and that would relate to algebra, and then they are following that rule as they sort the teddy bears. So we can give them lots of fun things to sort and classify, and they can put them into categories based on rules that they develop or that we suggest. Furthermore, they can then begin to pattern once they understand what an attribute is, that, oh, we could sort things based on color or based on shape or based on size. Then they can begin to put them into another relationship, which would be a pattern. So we could say, well, we're going to have a red bear, a blue bear, a red bear, a blue bear. We could even make it into a little chant. Red bear, blue bear, red bear, blue bear. And as soon as we begin to put that into a rhythmic context, sort of move with it, they seem to catch on really quickly to a pattern. And that's extremely important, because as they go on into 1st, 2nd, 3rd grade, they're going to be expected to make patterns and then apply those to the number system. So beginning to get a feel for what a pattern is and that repeating element is something very important that we can do in ages 3 to 5. Then we move on to geometry. And of course, we all think shapes. We do that. We have shape sorters. We have shape puzzles. We do that. But it's a lot more than that. First of all, in terms of shapes, most of those materials that we can buy will have standard shapes. So the triangle always pretty much looks like this. But triangles can be long and pointy, or they can be flopped on their sides. And as long as they have 3 straight sides that connect, they are still triangles. So if we make our own teacher-made materials, we can show them shapes that are not always in precisely the way their little shape blocks look. So we can make bingo games and those sorts of things so that they can see shapes in many different positions. Furthermore, and this is something we often don't think about, a lot of geometry relates to positioning and location. And so when we're using terms with children like above, below, inside, behind, next to the right of, that's geometry. And we can do that best when they're playing. So if they've built let's say they've built a barn in the block area, I can say, well, here comes my cow. He kind of doesn't want the horses to see him. So he's going to go and he's going to hide behind the barn. Did I get him behind the barn? Can the horses see him from where they're standing? Now what if he moves to the side of the barn? Can the horses see him now? So we can just play, but do it intentionally, because we know that what we're really trying to do is model those positional terms in a way that's meaningful to the children. And if it's part of their play, then it's meaningful. So then we go on to measurement. And measurement's a very interesting concept for young children. At first, it's mainly, well, my mommy's taller than my daddy. Or I'm taller than my little sister. Or that they look at 2 things that are next to each other and they may say, this is the big pine cone, this is the little pine cone. Eventually, though, they began to maybe want to measure some distances. I had one little girl who was 4 who was determined to measure the distance to the ceiling. And of course, she couldn't reach the ceiling. None of us could. And she starts putting some little manipulative cylinders together, the kind of thing that hooks together, and then stick it up. No, doesn't reach. Put some more on. And stick it up. Doesn't reach. Put some more on. She worked at least 40 minutes on this major project because she so wanted to touch the ceiling. And eventually, she did. And when she did that, the joy was all over her face. This was a really tough math problem, and she just solved it. And then we sat down together and we counted all of those little pieces, all of those little blocks, and that was how tall the ceiling was. It was something like 45 little cylinders tall. When children engage in this kind of activity, they're learning really important measure concepts like we need to use the same size unit. We couldn't use some little cylinder, some big, because then we wouldn't know exactly how many to use the next time we went to measure. They have to touch each other. If we have gaps, then we don't know the exact measurement. And these are all really important concepts that we can begin to explore through play with children, especially things that they're really interested in. In the block area, most of us have had the experience of a little conflict breaking out because somebody took all the long blocks and now I can't make my fence or I can't make my house big enough. And that's when we can move in and say, well, hey, look at these medium length blocks. I'm going to put 2 together and see what I get. Oh my gosh, they're the same length as Jeremy's long block. So even though he's using all the long blocks, if we just put these 2 together, we can go ahead and make our building as big as we want it. And then we can go further and say, and by the way, if we look at these that are even smaller and we put 1, 2, 3, 4 of those together, we now have one that's the same length as his long block. So he can have all the long blocks, so we can still do our building and make it really cool. So these are some of the really important ways that measurement comes out, especially in the block area. And then finally, there is an area called data analysis. When children are sorting their toys, that is their data. Their data is stuff that they're interested in, that they can touch, that's right there in front of them. And it's also things that they can vote on, like, are we going to have oranges, bananas, or pears for lunch? And then let's figure out which one has the most votes, and then we'll let the cook know. And we can make a small bar graph and put that on there. And if their names are on their voting tags, they can see, oh, look at this. We all voted for apples, but a bunch of the boys voted for pears. And which one had the most, and which one had the fewest. And so which one are we going to tell the cook that we're going to have for lunch this week? So those are 5 important areas in mathematics that all kind of intertwine and that we should specifically support through our interactions and planning with children in the preschool. A very important question for teachers of preschool children is, where do we start in terms of these numbers and these games and counting? We know that even many toddlers, and some people even think infants, understand 1 and 2. So if they see 1 object versus 2 objects, they can tell that they're not the same. And many 3-year-olds can look at 1 thing and say that's 1, 2 things and say that's 2. We also have research going all the way back to the 1950s that shows that young preschool children tend to first understand 1, 2, 3, and after that it's just a lot. original research was done in France, so it was un, deux, trois, et beaucoup. 1, 2, 3, and a lot. So with our young children, what we often like to do is to make our own dice or our own cards and limit the amounts at first to 3. So I would take like a 1-inch cube and use some round file folder stickers and put 1, 2, or 3 on each side. These are numbers that young children can grasp, so they'll be more quick to be able to use a more logical strategy like matching a dot to an item than if we gave them a card that had 10 things on it, which is just a lot, or even 6, which is just a lot. So at first, we almost always start with simple games where you have a die or a card that has 1, 2, or 3 dots. Very quickly, you will be able to tell if this is too easy for the child. And as soon as it's too easy for the child, then you can move to a 1 to 6 die. Still only 1 die, still a die with dots, because we're not expecting them to recognize the numerals at this point and to know what they mean. Later, we're going to find maybe our 4-year-olds who have had some experience that a 1 to 6 is duck soup. And so then we're going to give them 2 dice or 2 cards to draw. And you know what? When we do that, we move them right into addition. Yeah, they're still 4. And they begin to add. So let's say they draw these 2 cards. We can expect to, at first, they may think of them as separate. So they may go 1, 2, 3 and take 3 things, or move 3 spaces on the path of a game, and then 1, 2 and move that. But then they begin to realize, I could just put them all together. And at first they go 1, 2, 3, 1, 2, 1, 2, 3, 4, 5. But I have found that children who have a lot of experience with playing games move very quickly to immediately just combining them. 1, 2, 3, 4, 5, and that's addition. And so because they have the concrete objects that they can count, they have already moved into arithmetic operations, even in preschool. Now at some point, we're also going to model numerals. So when we have a counting song, maybe 5 little ducks, I might put that on a chart, and I might have a numeral 5 when there are 5. And then each time we take a duck away, we might change the numeral 4, 3. And I'm going to expect children, as they get older in preschool, to begin to associate a numeral, a symbol, that they would use might be 3 circles or 3 hash marks. We would use a more complex symbol, a 5 or a numeral, and hope that they understand that that means 5 objects. Research indicates that young children still need many opportunities to be using the actual dot die, because when we switch and use a numeral die, they can't move forward into addition. They may think that all of a sudden that numeral only means 1 object, even though they just told you it was 5. So for this reason, it's important to introduce numerals gradually, at first mainly modeling them, and then still give children the option of using the dice that have the dots on them. It's important in terms of their learning. But as a teacher, it's also important to consciously plan to integrate math with other curriculum areas. We know that we can put counting books out, but we can often put manipulative materials out so that children can model math in not just counting books, but story books as well. So a book that many teachers are familiar with is The Very Hungry Caterpillar. If I have a bowl of plastic fruit out, then the children can actually model how many strawberries he eats through, how many apples he ate through, how many oranges. But I like to trick them a little bit. I don't want to just put the exact amount in, because then all they have to do is find all the oranges. They don't have to think as much about the math. So I like to put in maybe more things than the caterpillar actually eats, so that they have to look to the book and make an association between what's on the page and what's read to them and how much the caterpillar really eats. Another thing that I think teachers have to be aware of is sometimes we may be misinformed about what the child means in response to a question we ask. So for example, let's say I have some little dinosaurs out for children to sort. And some of the children do it by color and some do it by type of dinosaur. And then I come over to Johnny, and Johnny's got some here and some here and some here, and they're all mixed up, and I see nothing. So I see nothing that links any group to the other objects in the group. I'm very likely to think, well, Johnny doesn't know how to sort and classify yet. Let me write that on my checklist. And then I'll have to very carefully make sure that we, address that, and maybe I'll ask him to do the red dinosaurs tomorrow, and et cetera, et cetera. Actually, this happened to me. And instead of doing that, I actually said, hey, Johnny, I see you've got groups of dinosaurs. I'm just wondering, how did you decide which ones went here and which ones went here? And Johnny says to me, well, first of all, I wanted 5 in each group. So I looked a little more carefully, and by golly, there were 5 in each group. And he said, but I wanted all 5 to be different types of dinosaurs. So in this one, I have these 5 types, and in this one, these. And I looked, and my goodness, this was so much more complex than what I was thinking any of the children could do. And I was about to write him down as somebody who couldn't even think about sorting and classifying. I remember one child who was special needs who was in my class who would not go near a math game. Now look, I make really cool math games. Everybody likes to play my math games. Well, maybe not. This child didn't. I couldn't get him near one to play it with me. But what he did like was dramatic play. So finally I decided, look, lady, meaning myself, you're not succeeding with this child. You better move your stuff to dramatic play. And so what I did was take a cookie sheet and some plastic tape, and I made it into boxes. I guess I could have just used a muffin tin, but I actually made it into boxes, like a kind of a bingo game. And I got some magnetic cookies, and I put a bakery over there. Next thing I knew, this child was running over, grabbing the cookie sheet, and I was playing bakery with him. I could then ask all the same things I would have asked if we had been using an actual math game. But because we were in the bakery, he wanted to play. And so we would fill up a row of cookies. We would count the cookies. I would say, well, give me one more and let me see if I have as many as you do. Or if you've got these many cookies, how many more do you need? Let's count them. And we did this for 3 weeks. At the end of 3 weeks, this child surprised me. He came and got my hand, and he led me over to an actual math game, and it still makes my eyes tear up. And he said, can we play this now? Because he taught me one of the biggest lessons of my teaching career. He needed to do what was hard for him in an area where he felt comfortable. We are all like that. And once he felt comfortable with the same math concepts, in an area where he could achieve and felt confident, then he could move him to the area where he felt less comfortable and apply them. And that was one of my biggest teaching lessons, and it's why I'm so opposed to only looking at children in a snapshot of a formal assessment. I think we need to be looking at where children can perform best and then helping them generalize it to other situations. At home, we might have them help us with the laundry. can you put all of your socks in one pile and all of your sister's socks in one pile? Can you match them up so that, because one pair of socks is 2 socks, which is a big idea when you're 3. Yeah, 1 pair, 2 socks. Can you make sure that everybody has a full pair of socks there? And that will really help me out. Then we can put them away really fast when we're done. When we're driving in the car, we might play a game like, let's count how many red cars we see before we get to the grocery store. I see 1, do you see that one? Okay, that's 1. There's 1, that's 2. Make sure you keep your eyes on the road. But things like this just sort of integrate math into children's daily conversations. If they are taking a walk with their children and they see some flowers growing, they might want to talk about how many of the flowers can we count that are yellow? How many are red? Do you think there are more red or more yellow? Or maybe we're walking by an aquarium, maybe at a pet store or maybe at a museum, and we might want to compare, are there more big fish or more little fish? Are there more red fish or more white fish, whatever. I'd like to end by talking about math and how many of us as teachers may feel about math. Frankly, a lot of adults do not like math. They did not like math when they were in school. They may have even decided to work in the younger grades because there wouldn't be much math. But as we can see now, there's a lot of math, even if you're in the toddler class. Here's what I want to say. Math is important. We need to think about it. We need to plan for it. And we need to dip our toes in the water and start doing it. And this is what I have found. The more you talk with children about math, the more you discover that they like math. They think math is cool. And they think you're cool because you can do math that they can't do, and you can play with them in terms of math. You can sing songs about math. You can show it with finger puppets and little items. And they think you're a rock star when it comes to math. I found even with myself personally, as a preschool and kindergarten teacher, the more I did math and the more I allowed children to use their own thinking strategies, with me helping just enough so they could use their own thinking strategies, the more I began to realize we can think about math in many ways. It's very creative. And I, too, can now allow myself to think about math in many different ways. Instead of seeing a problem that I think, oh, this is going to be hard, better go have somebody tell me how to do it, I now find it's quite fun to sit there and think about it. And I also find that when I do that, chances are I can work the problem. It's interesting because this is exactly the same idea that math educators are working now in elementary, middle, and high school to have students feel. There's not just one way to do any kind of math. We can all do it, and we can share our strategies. As teachers, we need to start having fun with math. If we're not, we need to at least act like it. And if we act like it, we may actually convince ourselves that, hey, this is kind of fun.